Hello, everyone. Thank you for having us here in London. Happy to be here with Mateus.
Yeah.
We work for Site, Site.to. We are the best platform to host static and dynamic websites. And we are here to talk to you about Jedis. First, we're going to go through a quick introduction. Then we're going to talk about Jedis and streams. And then we're going to show you a demo. So we were thinking about trying to showcase the traditional use case of running an application and how it works with streams. But specifically for today, we are trying to go a bit further, and we're going to try to open your mind with a new paradigm of working with Jedis and Java in general. So I'm pretty sure that many of you saw the title of the presentation and maybe thought, okay, Jedis. No, Jedis. For those who don't know, Jedis is the most used Java client for Redis, right? It's a project that I'm currently maintainer of. I've been working in Jedis for several years. I'm not very active at the moment, but the community is still vibrant and they're still contributing a lot. So these were the expectations, but in reality, what we got was this, lesson number one, don't use incorrect hashtags because you don't want to mess with the Star Wars community, right? you might get this feedback. Lesson number two, it was interesting for me to come back to Java because it's been a while since I don't code in Java. I'm mostly Node.js and Go now. And when I came back for this presentation specifically, I realized that I had to go back to all my old tooling. All this stuff around the Java ecosystem. So just to get an idea of the audience, how many of you are using Java at this moment with Redis? Whoa. Okay, maybe nice. 10, 20%. So sorry for all the bugs that I introduced in the code. That wasn't intentionally, but that's the way it is. That's how open source is. If you have any questions regarding Jedis or Java, just let me know. We can talk about it later regarding roadmaps or whatever. So let me tell you a little bit how Jedis started, right? So this happened around 2010. I think it was, back in the days, it was Oracle. No, it was Oracle. It was Sun, JDK 6 and 5 and 6 or 6 and 7. And we were using Redis. I don't know if someone recalls that project, at MercadoLibre.com. MercadoLibre.com is the biggest e-commerce platform in Latin America. By the way, I'm from Argentina, and Mateus is from Brazil. And Mercado actually has 150 million requests a minute. It has more than 200,000 VMs in production. It's a really, really big company, 30 million market cap. And we're basically using Redis. And Jonathan, which is the original author of the library, he's a friend of mine, he wanted to implement a new command in Redis, right? So basically, he tried to go into the open source repo, the Redis one, like pretty much what everyone does. And then he saw that the current client back in those days wasn't really supported. So he tried to contact the maintainer, and the maintainer told him, hey, I don't really have time to put more effort into this. So, and he also saw that it was super difficult in regards to the X, right? Trying to run commands in that client was a bit painful. So then he started thinking, and he said, okay, I'm going to try to come up with something better. I'm going to try to implement the very minimum subset of things that I need, like get, set, whatever it was back at the time, maybe lists, and the command that he was needing. And then during one night, he came up with Jedis. The thing is that when he tried to put his client in production in Mercado Libre, which is a big company, as I said, then everything blew up over the air, right? Because it's difficult to actually code a client to be performant and also reliable at the same time. So after that, he realized that he needed to take it to the next step, right? So, and that was the manifesto he came up when he created Jedis. I don't know, for those who are using Jedis or have ever used it, you're going to see that the GitHub doesn't move that fast, at least for now. But the manifesto was basically based on these three premises. The first one is performance and easy to extend. If you actually see the Jedis repo, you're going to see that it has a lot of interfaces and nice Java things around it. And the main idea is for you to easily extend it. You just need to create a new method in an interface, then implement that interface, and that's it. The second premise is that the fact that it is extremely well tested. If any of you have ever tried Jedis or download the source code or try to compile it, you're going to see that it takes a bunch of time to run the whole test suite. Why? Because we just actually spawn several Redis servers on your machine whenever you run tests. We even spawn 3 clusters at the same time because we try to test as much things as we can. We test Sentinel, we test Jedis cluster, we test a bunch of things. But the most important thing was the best possible DX. I don't know if, well, I'm going to show some examples of the API, but the idea here is that if you're thinking about an operation like set, get, or anything, it should be straightforward the way to implement it. You wouldn't have to use generics or any kind of funky stuff to get a intuitive API. I can't really go here without saying thank you to all those contributors. They are the ones who are actually making Jedis like what it is today, used by many companies, like the official also library for Spring Data. If anyone is using Spring Data, it also uses Jedis by default. But okay, so let's talk about the streams. So we promised you that we're going to talk about streams here, and we also have a cool demo that Mateus is going to show us. So what's the deal with streams? So the support for streams, as you can see, it landed around a year ago, and it was basically it took some time to get there, mostly because the DX that I was mentioning, right? As you can see, there was a long discussion in GitHub, even though only 20 files were modified to implement it. We actually took a lot of time to think how someone would use it, given the original Redis commands. For those who don't know what streams are for, you can think about it in a super easy way as a pub sub with state, right? You can just send the message will get stored in the stream, and then you can consume it from either one or many consumers. That's the building blocks of streams. You have an example here on how managing streams looks in Jedis, right? For example, the xr command, which is adding a message to a stream, is just basically doing Jedis xr and then setting up the stream name. Additionally, you can set the ID of the message that you're sending. That is like a millisecond timestamp, and then you set the key value objects of the things that you want to send. As you would imagine, you can set maps of string and any type. In this case, I'm choosing to use string, but you could set any type you want. You can set bytes, objects, serialized objects, or whatever, right? Same thing goes for reading stuff from the stream. The API here gets a little bit more complex because the xread operation has a lot more configuration options. Basically, you can set the count, the block in milliseconds, and this is how the way that you use it in Jedis. We are using variable arguments in the last line here, because whenever you are reading from a stream, you can also set multiple streams to read messages from. Another important thing that I would like to highlight is that because Jedis has a really comprehensive test suite, you can actually go into that source file and see all the operations for streams that are tested there, basically. So we test the length, we test the pending messages, we test the ACK. So you're going to be able to find everything there. So now I'm going to leave Mateus to show you this idea about opening your mind in regards to how to code this.
Yeah. So as Marcos was saying, a few weeks ago we were trying to come up with what we could show here, right? There's a few very classical use cases for streams, right? But we just really wanted to come up with something that you don't necessarily need to use streams for, but we wanted to show how Redis, I mean, everybody here pretty much knows that Redis is extremely flexible, right? But we also wanted to highlight how flexible Redis streams are, right? So if you go to the demo here, I think that's big enough. If anybody wants to access, by the way, it's publicly accessible. It's called Redis stories.now.sh, right? We just pretty much came up with Instagram stories, but for Redis, right? I think a few months ago or maybe a year ago. This was a meme, right? Everything had a story. So even Redis has stories now. And pretty much how this demo works is just a very basic implementation of a stream, right? You can come here in the homepage. We're polling. We keep polling the Redis streams, as you can see. And we just read the past 30 seconds of the stream, right? And if you go to the post, as you can see, the stories are only valid for 30 seconds, right? It's like Snapchat, but really fast. You can only see something only see what was deployed in the past 30 seconds. So if we come here, we can just post a message. It just immediately sends the message to the stream, and then it refreshes, goes back to the home, and you can see that it's extremely fast, right? We are just running these serverless functions, which, by the way, this is powered by serverless. I'm going to talk a little bit more about it shortly. But this is powered by serverless, and you can see that it's extremely fast, right? There's a little bit of deviance here, but pretty much everything you can just read the stream in 30 milliseconds, right? And the functions are running here in London, and the Redis instance on Redis Labs is running in Dublin. So you can do all of that SSL, TCP handshake, and everything. I mean, sure, with the deviance when verify, but in just 40, 50 milliseconds, you can do all of that. Yeah. So now just a little bit on the very basic architecture here. As I mentioned, this is serverless, right? This is not your typical Java application whatsoever, right? It is, but it's not, as I'm going to show later in the code. So how it works basically is that when you access the front end, right? The front end, which is powered by Next.js, there's just two API endpoints. You can either get stories or you can post stories, right? And as you can see there, each of those are separate Lambda functions, right? We have the OpenJDK there sitting in a coffee mug. They're separate Lambda functions, right? They scale independently, they run independently, they break independently of each other. So it might be that you break story creation, but you don't break story retrieval, right? And then each of them, the get stories and post story, they just communicate to the Redis stream, as Marcus said, with the amazing Jedis API, with basic xadd and xread streams, right? And I would like to show the code real quick. We may be running out of time, I believe, but I think I can show the code real quick. So yeah, as I mentioned, this is, but it's not your typical Java application, right? So you just have basic Java code, right? And you just have, for the sake of simplicity, we just got rid of packages. We're using the no packages, just package main. And as you can see, this is really just basic Java, right? We're just doing the most basic thing you can do in TCP, just HTTP, right? We don't expect you to use any proprietary thing we came up with. We don't expect you to use any proprietary file, like a Tomo or anything special that we came up with. It's just basic HTTP, right? You just get the HTTP request, you send it to, in this case is the consumer. So you just read from the stream and send the response to the user as basic HTTP, right? And the producer is the same thing. You just receive the body that the user sends and just send it to the stream on Redis. No proprietary protocols we came up with or anything like that. The only thing we ask you to do is, if you're using now, you just need to tell us, hey, for Java files, just use the Java builder, right? It's pretty much like a Docker file, but JSON. Right? You just need to use the Java builder. Then you can set other things like the region. You can set your API routes. And yeah, I mean, this is just pretty much as simple and as easy as it gets, right? And one interesting point that I would like to highlight here is that this looks like a monolith, right? There's no, if anybody, I'm pretty sure you guys are familiar with microservices architecture. There's no hundreds of GitHub repos. There's no hundreds of different projects, right? It's just one project that looks like a monolith, right? But then if you use our serverless platform, we actually spin off each of those Java classes to different serverless functions, right? You don't need to think in a serverless way or in a microservice way. You can just think in a monolith way. You just write your code and you have your Git repo in a monolithic way. And we just, without you having to do any heavy lifting or any extra overhead, we just transform that into a serverless model for you. So just a very few key points, just a few takeaways here that we had. If you're using serverless, it's important that you optimize for very small bundle sizes, right? So you don't want to have a gigantic serverless functions that every time there's a new request, you're going to have to load gigantic amounts of Java in memory. Right, so as I said, you have a monolithic approach, but then we transform that into a microservice approach for you, right? Each Java file gets automatically transformed into a separate Lambda function with the minimal amount of code, the amount of dependencies needed for that specific piece of code that you have. So the consumer, it might be that the consumer needs Jackson, for example, but the producer doesn't need Jackson or doesn't need JSON, right? So each piece of code, each endpoint gets its only tree shaking and its most optimized sets of dependencies. Another thing that we do for you is that we only build and deploy what you changed, right? So let's say that you have 200 endpoints, and you only changed the one that creates the stories. We're not going to deploy the entire. We're not going to build and deploy the entire application again, right? If you only changed the endpoints that create stories, we're only going to build and deploy that. Everything else remains unchanged. We just reuse the same serverless functions that are already there, right? And as I mentioned before, you have a monolithic structure, but a microservice-like deployment, which gives you best of both worlds, right? If you're managing code on source control, it's much easier to manage a monolith than hundreds of different microservice repositories, right? And another interesting property of serverless is that you get a one-to-one relationship between a request and a Unix process, right? So for each of those you guys that are accessing there, and for each of those pollings that I'm doing, they're all being handled by separate serverless instances, separate instances of the serverless functions, right? So if, for example, it happens that one of these requests triggered a kernel panic or triggered an infinite loop or triggered a memory leak, nobody else is going to be affected, only this specific request, right? That's a very important and interesting property of serverless, right? Only the specific request that was served by the specific instance of the serverless function gets affected by whatever bad might have happened on that request or whatever outlier you might have on that request. And let me see if I missed something. I think that's pretty much what I wanted to cover on demo. So we have just a little bit more.
Just to wrap up, thank you, Mateus. Just to wrap up, the last thing that we just want to say before leaving is that it's interesting to think of these problems, like for example the stories with these new structures and with these new features of Redis. Because, for example, if we would have wanted to take this our simple example, which just uses one stream, and have something like multiple users in our stories platform, we just had to use consumer groups in streams, and that would have enabled us automatically the ability to scale it up and to reuse the Lambda functions in the same way. So that's basically what we wanted to leave you with, the idea of bringing Java into this new world of cloud services using Jedis and of course the features that Redis offers. Thank you very much.
Thank you.